In this video, we'll be looking into the Turing machine model, the theoretical topics. So firstly, understanding the definition of Turing machine. So Turing machine consists of a tape that are divided into cells. So let's take this as a tape which are divided into further small cells which can store one symbol at a time. So the tape is a two-way infinite tape. So the tape here, with the help of finite control, it could move left or right. Okay, so that's what it said as two-way infinite tape. So the external memory present can arbitrarily remember long sequence of input. Memory capacity is unlimited. So that's one of the added advantages of Turing machines. So let's understand the given diagram here. So this is the tape. So one tape which is divided into multiple number of cells here. So each cell can store one symbol. So when you are dealing with this tape, you need to always start scanning from leftmost to the blank here. So whenever you encounter blank, that means that the particular values which are stored are completely read. So coming to the read-write control here, so this arm, so either read-write, it can either perform the read operation or the write operation on one cell at a time. So it can read a symbol from where it is pointing to, and it can write into the tape where it is pointing. So it can read this or it can write in this particular position. Coming to the finite control, it is also called as a control unit. So this determines whether the read-write head should whether the head should perform read operation or write operation, and it even controls the it should move left or right. So that was about this diagram, understanding the model here. So coming to the actions of Turing machines depend on the current state and input symbol, and it also involves change of state. So the state could either change or it could remain in the same state. So writing a symbol in the cell that is scanned, so depending on the symbol it can also vary. So the movement of read-write head, yes, of course, and whether to halt or not. So halt condition would be encountered. So this condition also plays an important role to determine the action of the Turing machine. So representation of Turing machine. So we make use of the instantaneous descriptions, the transition tables, and transition diagrams or graphs here. So the language accepted by Turing machine is called as recursively enumerable language. So understanding, next, let's look into the proper definition of Turing machine. Turing machine can be defined as 7 tuple. So it comprises of 7 tuples. Firstly, Q. So Q, sigma, tau, transition function, Q naught, B and F, where Q, we know that it's finite non-empty set comprising of F final states. Yes, it comprises of all the states, and sigma comprises of all the input alphabets. Tau comprises of the non-empty set of tape alphabets. Then transition function is here defined as Q cross tau to Q cross tau, and it can move either left or right. So we'll understand this once we start solving the problems. Then here we have Q naught being the initial state or the start state, B being the special symbol called as blank, and F being the final state or accepting state. So understanding what instantaneous description is, so we know that instantaneous description denotes the sequence of moves made by Turing machine. So it's represented like this. Okay. So during a specific execution, a configuration of Turing machine decides further behavior, which consists of the state, non-blank portion of tape content to left of head, that is alpha 1, and non-blank portion of tape content to right of head, that is alpha 2. So it is represented in this form, in 3 tuple form, that is alpha 1, Q, and Q1 and alpha 2, Q1 being that particular state. So instantaneous description of Turing machine is defined in terms of entire input string, yes, and the current state. Here the current state which we have considered as Q1. Okay. So moving on to understanding how it is represented. So consider this tape which has Q3, Q1, Q2, Q1 as the elements, as the string which is input, B and B defining that it starts from here and it ends here. Then the read write head points to A2 symbol on the tape. Yes, the state here is A2 as it is representing A2. So hence we can write A2 to right of Q2. On LHS the string takes Q3 Q1. So on LHS we have A3 and A1, and on RHS we have A1 and A1. So it could be represented as, so it was in state Q2 initially, yes, and it is pointing to A2. Present current state of Turing machine is Q2, and it is pointing to the symbol that is A2 under read write head. So on left of A2 we have A3 and A1, and on right of A2 we have A1 and A1. So this is how the instantaneous description is represented. So I hope you have got the basic understanding of Turing machine, and like you have understood how it is defined and what is the instantaneous description. We'll understand this in depth once we start solving the problems. If you have any doubts, do let me know in the comments, and subscribe to my channel. Thank you.